Hello students, today we will study the second property, that is commutativity, right? This is the topic of chapter number 1, standard 8, rational numbers, right? In previous class we have studied the closure property, right? So now this is the commutativity, right? So what is the mean by commutativity? Right? Suppose there are two numbers A and B, and if we apply the addition operation between A and B, and if we get the result by reversing this digit, right? We reverse the digit and apply the addition operation, and in both the case, if the result is equal, then we can say that two numbers are of commutative property, right? That satisfy the commutative property, right? So here we will see, here we will learn for the rational numbers that if the rational numbers are satisfy the commutative property or not. So for that we will take two sets, one is integers and second one is rational numbers. So by comparing this we will study this commutativity, right? So this number set is this and rational number set is this. This you know very well now, okay? So first of all we will see the addition operation, right? Take any two numbers from this integer sets. One is suppose -4 and second one is 2. So what is the result? -4 plus 2 is equals to -2. And now what is the result if we reverse the digit? That means first we take 2 and then second we add -4 to this, right? So now again the result is 2 plus -4, that is equals to 2 minus 4, and the result is -2. See, the result in both the cases is same. So that we can say that integers are commutative under addition operation, right? Now what is the case for rational number? See, first number is 2 upon 3, second one is 5 upon 3. By adding this, what we will get here is 5 plus 2, 7. Denominator is same, that is why no need to take the LCM. Denominator remains the same, 7 upon 3. Now reverse this digit. First we take 5 upon 3, then we add 2 upon 3, right? So by the addition of these two numbers is again we will get 7 upon 3. Both the results are same, that is why rational numbers are commutative under addition, right? Second operation, subtraction. For integers, two numbers, one is 5, second one is -3. We are applying subtraction. So what is the result here is 5 minus minus plus 3. 5 plus 3, 8. Now reverse the digit. -3 we will take first and 5 as a second number. So -3 minus 5. Now what is the result is -3 minus 5, that is equals to -8. Both are equal? No. Here the answer is 8, here is -8. So both the results are not equal, that is why integers are not commutative under subtraction, right? Or subtraction for the integers are not commutative, okay? Now for the rational numbers, one is 9 upon 7 and second one is 6 upon 7. So by subtracting this and by reversing this digit, first we take 6 upon 7 and then 9 upon 7. So there is a question, are both the results equal or not? So here what we will get by subtracting this, we get 9 minus 6, that is 3. Denominator is 7. So this result we get 3 upon 7. And right hand side what we will get, 6 minus 9, that means -3 upon 7. So this side we will get plus 3 upon 7, this side we will get -3 upon 7. So both these results are equal or not? No. Both these results are not equal. That means for the rational numbers, subtraction commutative is not satisfied, right? So now for the third operation, multiplication. Take two numbers 10 and 6, result is 60. Reverse the digit, 6 and 10, again the result is 60. So we can say that the integers are commutative under multiplication. For the rational number also, one number is 1 upon 4, second one is minus 5 upon 2. So this equals to, by reversing the digit, what we will get? First minus 5 upon 2, then 1 upon 4. So this result and these results are equal, and both are minus 5 upon 8. Left hand side is also minus 5 upon 8. Right hand side is also minus 5 upon 8. So both these results are equal. That means for the rational numbers are commutative under multiplication, right? Here this is not equal, and that is why here the question mark is given, right? So don't confuse between these two, right? Third is division. See, 7 divided by 3, we get the result 7 upon 3, and 3 divided by 7, by reversing the digit, here the result is 3 upon 7. So is 7 upon 3 and 3 upon 7 equal? No, they are not equal. So integers are not commutative under division. Same way for the rational number, 8 upon 5 divided by 7 upon 3, right? So by solving this, we will get the result 24 upon 35. In the same way, now reverse the digit, 7 upon 3 divided by 8 upon 5. So here we will get 35 upon 24. So both these results are equal. Again there is a question mark. So we know that 24 upon 35 is not equal to 35 upon 24. Right? So we can say that the rational numbers are not commutative under division. So the conclusion for the commutativity property is that the commutativity property for the rational number is applicable under the addition and multiplication, but it is not applicable under the subtraction and division. Now we will study the third property, that is the associativity property. Okay. So this is the for associativity property. So what is associativity property is, if we add three numbers by taking two numbers in the bracket, and now we regroup the number. So first of all we group the second and third number, and then we will group the first and second number, and in both the case if the result is equal, then for these numbers the associativity property works, right? So for the rational number and for the addition operation, we will take three numbers, first number and two numbers in the bracket. So first of all, by applying the addition for these two numbers, we will get this result, and by now adding this result with this number, we will get the answer minus 9 upon 10. Now we will regroup the number. So first of all we take these two numbers, and this number will be outside. So by simplifying this, we will get the 9 upon 10. The same result we will get here. So we can say that for the rational number, associativity works under the addition operation, right? For the subtraction, now for this same thing we will do. These two numbers will first apply the subtraction, so this number remains the as it is. By simplifying this, we will get this result. Now by this result and this number we will apply the subtraction, and by simplifying we will get the result 19 upon 30. Now we will change the group. So first this take this two number, this number remains the outside. So by simplifying this, we will get the result is minus 11 upon 30. Here you can see that the numbers or the results is not same. So we can say that the rational numbers are not associative under subtraction. Multiplication. This number remains outside. We will multiply this first. So the result is this. Now by this result we will multiply this number. So finally we will get minus 35 upon 54. Now what we will do, we will make the group of these two numbers. So 2 upon 9 remains the outside. And by simplifying this, you can see that we will get the result 35 upon 54. The same result we will get here, minus 35 upon 54. So we can say that for the rational number, associativity is applicable under multiplication, right? Now for the division, see, for division also, let's take these three numbers, right? So the number here is this. So by simplifying these, what we will get? This number, and by further simplification we will get the number minus 3 upon 5, right? Now we will regroup the numbers. So first of all we will take these two numbers, and 2 upon 5 remains the outside, and by simplifying these we will get the result minus 54 upon minus 15 upon 4. So this result and this result are not same. So we can say that the division is not applicable for the associativity, for the rational numbers. So what is the conclusion for the associativity is that associativity property for the rational number is applicable under the addition and multiplication only. It is not applicable for the subtraction and division, right? So this is all about the property of the rational numbers, right? Further, we will study in the next class. Okay? Thank you.